Hey guys, this is Miss Noland here, and today we're going to talk about logarithms as inverses and as graphs. So we've reviewed before, what is an inverse? So for an inverse, the key step that we need to remember is that we're switching our x and y values. So we've seen that the inverse of a linear function, right in this example right here, the inverse of a linear function is still a linear function. But if we're looking at what we're talking about today, the inverse of an exponential function is going to be a logarithm. So for graphing the inverse functions, we are going to make sure that we reflect across that line y equals x. That means that we're taking our x and y values and we're switching them. Also thinking about how an exponential function would have a horizontal asymptote. Now, in a logarithmic function, that's going to switch and it's going to become a vertical asymptote, as well as the domain and range is going to switch. So let's first start off by just trying to find the inverse of some specific functions. So to find the inverse of a function, we need to start off by switching x and y. So I'm going to write down that x equals 2e to the y plus 2. So I've switched x and y. I'm going to isolate my exponential term by dividing both sides by 2. So I get that x divided by 2 equals e to the y plus 2. Whenever we have an exponential, we want to convert it to a logarithm. So that's going to be log base e of x divided by 2 equals y plus 2. The final step is going to be to subtract the 2 from both sides. And then log base e is the same as ln. So I'm going to get that y equals ln x divided by 2 minus 2. And then for an inverse, if you guys remember, the symbol is a little -1. You might have seen that symbol before when we talked about trig. So remember, if you saw sine inverse, remember it had that little -1. So that would be our final notation. We're going to do another one of these problems. Start off by switching x and y. So I get that x equals 3y minus 4 plus 7. Start off by isolating my exponential term. X minus 7 equals 3y minus 4. Now I'm going to go ahead and convert this to a logarithm. So the base is the base. So that's going to be log base 3 of x minus 7 equals y minus 4. The final step is to add the 4. I'm going to go ahead and write my final answer up here in blue. So inverse, so that's going to be y inverse equals log base 3 x minus 7 plus 4. So that's how we find the algebraic inverse of an exponential function, writing it as a logarithm. But let's take a look at what we're going to do with our graphs. So let's start off by graphing the exponential function that we have right here. So if I start off by making a little XY table, I'm going to say, okay, when I plug in -1, that's going to give me 1/2 plus 1, so I'm going to get 1.5. When I plug in 0, I'm going to get 2. And when I plug in 1, I'm going to get 3. So let me start by plotting these. So -1, 1.5. 0, 2, and then 1, 3. It looks like this function is going to have a horizontal asymptote at y equals 1. Remember, our horizontal asymptote was equal to that vertical shift. So let me go ahead and do my best to put that on the graph. And then I'm going to go ahead and draw in my exponential function. So it's going to look something like that. Now, if I want to find the inverse, let's go ahead and find that algebraically first. So I'm going to say x equals 2 to the y plus 1. Subtract 1, isolate your exponential term. So x minus 1 equals 2 to the y. Convert this to a log. I'm going to get that y inverse equals log base 2 of x minus 1. So now if I want to go ahead, there's my inverse. If I want to graph my inverse, remember that to graph my inverse, I take my x and y values and I switch them. So instead of plotting -1, 1.5, now I'm going to plot 1.5, -1. I'm going to plot 2, 0. And I'm going to plot 3, 1. And for this function, it's going to look something like this. That's my logarithmic function. Let me see if I can just get a different color here. Let's do this light blue. And that's going to have a vertical asymptote at x equals 1. So you can see right there, those two graphs, they are a reflection over that line y equals x if we drew that on in. So there we go. We've graphed a log function. Now, you might wonder, are we going to have to do all of these steps every single time? Are we going to have to graph an exponential function, find the inverse, and do all those steps? No, we're going to actually have some steps right here, 1, 2, 3, 4, 5, on how to graph a logarithmic function in its own. So the first thing we need to do is we're going to start off by graphing these 2 points. So this first point, 1, 0, that is called our anchor point. So let me see if I can get that in there. Anchor point. So that's our anchor point, and then the other point I like to call the base point. The reason why I call it the base point is because B stands for base. So we're going to graph a little x at those 2 points. So at 1, 0, so at 1, 0, I'm going to graph a little x right there, and then I'm also going to graph a point at base 1. So in this case, the base is 3, so that point is going to be at 3, 1. So those are my first 2 points. To find the asymptote, we take whatever is inside the parentheses and set it equal to 0. So in this case, we're going to have a vertical asymptote at x equals 0. Okay, and then we're going to see how the graph has been shifted. It looks like in this case, there's going to be no transformations. So we're going to say, okay, well then that means that my points are definitely going to be 1, 0. And then my other point is going to be 3, 1. So these actually are my points, so I can just kind of fill those guys in. And then there we go. I can just draw my new dots, and I can go ahead and draw in my logarithmic function. I'm going to just make sure that I have my vertical asymptote put in there as well. And then if we want to just go ahead and write in some information about this graph, we would say that I have a vertical asymptote at x equals 0. If I'm thinking about my domain, that's going to be restricted from my vertical asymptote to infinity. And then for a logarithmic function, my range is always going to be all real numbers. So let me see if I can get this eraser to work. There we go. Range is going to be all real numbers. So there we go. Let's go ahead and do these steps for this next function. So I'm going to start off by drawing my x at 0, 1, and then at my base point, which in this case is going to be 3, 1. Let me go ahead and draw those in. Now we're going to set our parentheses equal to 0 and solve. So x minus 2 equals 0. So in this case, my vertical asymptote is going to be at x equals 2. So let me go ahead and draw that in. So that's x equals 2. There we go. Decide how it's been changed. So it looks like that minus 2 means I'm going to go to the right 2, and then I'm going to go up 3. So I need to translate these points. So instead of being at 1, 0, that point now is going to be at, so if I'm going right 2, so instead of being at 1, now it's going to be at 3. And instead of being at 0, it's going to be at 3. So my new point is 3, 3. And I'm going to do that the same thing. My base point was originally at 3, 1. But now I want to add 2 to that value. So that's going to give me 5. And then up 3, 5, 4. So these are the 2 points I'm going to graph. For log functions, I'm only going to be looking for those 2 points. So now these are my 2 points. So 3, 3. Let me make sure I got that in there. And then 5, 4. Right there. So I only need those 2 points, and then you guys can just kind of have it hug the asymptote on the other side. So for this function, if we want to make a note about the domain, my domain is going to be from my vertical asymptote, which is this case is at 2 to infinity, and that range is going to stay constant at all real numbers. So now we're going to go ahead and practice some functions on our own with graphing them. So the first thing I'd like us to do would be to write out the transformations. So right here, the negative in front, that means we have a x-axis reflection. We're going to go to the right 1, and we're going to go up 1. So let's think about those 2 original points. The anchor point is going to be at 1, 0. And then our base point is going to be at base comma 1. So that's going to be at 5, comma 1. First, think about x-axis reflection. Well, what does an x-axis function reflection mean? So if you guys remember the transformation rules, an x-axis reflection meant that x stayed the same and that y changed sign. So my first step is going to be to change the signs of the y values. So my y value, 0 times -1 is 0. And then 1 times -1 gives me -1. Then let me go ahead and transform right 1. What does that mean? Well, that means that the x values are going to add 1. So 1 is going to become 2 and 5 is going to become 6. And then let's think about the last step. It says up 1. So 0 is going to become 1 and -1 is going to become 0. It's important that you do your multiplication before your addition, keeping consistent with the order of operations. So then that leads me with my point now at 2, 1, and my other point at 6, 0. So remember, only 2 points to graph a log. So I have 2, 1, and then my other point is going to be at 6, 0. So I have those graphed. To figure out my vertical asymptote, we had said that you take whatever's in the parentheses and set it equal to 0. So my vertical asymptote is going to be at x equals 1. And if this has been reflected over the x-axis, now my logarithm function is going to be going the opposite direction. So it's going to look something like that. And my domain is still going to be from my asymptote to infinity. So that's from 1 to infinity. And that range stays consistent at all real numbers. And we just have one final function to graph. So let's take a look at this one right here. A base of 1/2. That's actually going to show that I am going to have a reflection right there. So that means I am going to be having that reflection, but that's just going to be reflected in the base point. So the anchor point is still going to be at 1, 0. My base point is going to have that 1/2 comma 1. Now we're going to have to try to figure out what transformations have happened right now. So transformations, it looks like the only transformation that I have is that the function went down 3. So that means I'm just going to subtract 3 from my y values, which means my point is going to be at 1, -3. And then it's going to be at 1/2 comma. And then when I subtract 3, that's going to be -2. So these are going to be my 2 points. So I'm going to go ahead and graph them. So I have 1, -3 as a point, and the other point is going to be 1/2 -2. That's really close right there, but it's going to be right there. And then we're going to say, okay, to find my vertical asymptote, we took whatever would be the argument, whatever's in the parentheses. In this case, it's just x. So my vertical asymptote's at x equals 0. So I'm going to sketch that in. And then right here, we kind of see which way it's going. It looks like it's going down like that. And then on the other side, it's going to go up to infinity. So for my domain, it's going to still be the asymptote to infinity. So that's going to be 0 to infinity. And my range is going to be all real numbers. And there we have it. We've graphed some logs.